Hello everyone. Today I would like to do overview of the derivative stuffs you have to know for your upcoming AP Calculus exam. So we'll go ahead and get started. So first of all, the definition of a derivative is f prime of x is equal to the limit of h approaching to 0 and f of x plus h minus f of x divided by h. Okay, so this is the formula you should know when you're trying to find the derivative of a function with respect to x. And then, of course, you can use the limit here. So let's go ahead and try solving an example. Uh, by using this theorem over here, let's go ahead and find f prime of x for a function where it's x squared plus 3x. So f prime of x is equal to, I'll go ahead and say limit h approaches to 0, um, x plus h squared, all of that squared, plus 3, x plus h, and then let me just put that h here, minus x squared plus 3x. I'll go ahead and solve that right now. X squared plus 2xh plus h squared plus 3x plus 3h minus x squared. Oopsies. Should be just here. Sorry about that. It should be a minus, there should have been a, this is here. So with that, 3x, and then divided all of that by h. So you'll get, so this will cross out. The 3x will also cross out. So we'll have 2x h plus h squared plus 3h, all of that divided by h. Oops. And I can go ahead that and write it as this. Okay. Now, we need to apply the limit of when h approaches to 0. So all you got to do is replace the h with 0. So 2x, and this becomes 2x plus 3. Sorry about the forgetting to put the parenthesis here, but this is how you can get the derivative of f with respect to x using the limit definition above. So yeah, there you go. So I'm going to be covering some basic differentiation rules. So first of all, the power rule is when you take the derivative of a function with respect to x of, let's say, x to the power of n, it becomes, you bring down the n in front. So it becomes n x to the power of n minus 1. Also, like the derivative of any constant. So let's say you're given a c, and I take the derivative of that c with respect to x, just simply becomes big fat zero. Okay. And let's say you have a function of, let's say, c f of x. Okay. And we want to take the derivative of that with respect to x. All you got to do is pull out the c to the front and then take the derivative of the function f with respect to x. So I could write that as c of f prime of x. Okay. And for summation and differences, this is pretty straightforward. Let's say I have a function f of x plus g of x, or like f of x minus g of x. And you want to take the derivative of all of this with respect to x. All you got to do is just, apply the derivatives with the functions respectively. So becomes f prime of x plus g prime of x for summation. And for difference, all you got to do is f prime of x minus g prime of x. Okay, there you go. Um, I'm going to use Now I'm going to talk about the product rule. So product rule is when you have like a function fg together, and if I want to take the derivative of fg, all I gotta do is f prime g plus f times g prime. Let's solve an example problem together. So let's say we're given a function f of x is equal to x squared sine of x. Okay. And I want to find f prime of x. Well, as you can see, I can clearly see two functions, x squared and sine of x. So what can I do? I'm going to first take the derivative of x squared with respect to x first. But remember, keep the sine of x here, okay? Because according to the product rule, when you take the derivative of the first function, you need to multiply with the function of the second function. And then you would want to add the first function with the derivative of the second function. So you keep the x squared here. What is the derivative of sine of x with respect to x? Well, it's cosine of x. So this is how you apply the product rule. Okay. And moving on to quotient rule, let's say you're given a function f over g, and you want to find the derivative. So all you got to do is on the denominator, you square the g, so the second function, and then all you got to do is f prime of g minus f times g prime. So looking back to the product rule, um, The only difference is that for the quotient rule, you'll see a minus sign here instead of plus, and you need to divide it by the second function squared. So keep that in mind when you're looking into both product and the quotient rule. Okay, so here is a function. Um, let's say f of x is equal to x over ln of x. As you can see, we have the first function here, x is our first function, and our second function, ln of x over here. So by using the quotient rule, I'm going to go ahead and then place ln of x, all of that squared in the denominator. So ln of x, all of that squared. Now I'm going to go ahead and take the derivative of x with respect to x, which is 1, and keep the ln of x. So we have 1 times ln of x, and then minus, keep the x because we need to take the derivative of the second function, which over here is ln of x. So uh, the derivative of ln of x with respect to x is 1 over x. So I'm going to go ahead and multiply that here. Okay. And oops, here we go. So f prime of x is equal to ln of x minus 1. And yes, don't forget to divide it by ln of x, all of that squared. Okay. Now we're given a function here, and this is a nested function. Okay. Now, if we're going to take the derivative of a nested function, we use the chain rule. So if I want to take the derivative of this nested function with respect to x, all I got to do is first take the derivative of the outer function, keep everything inside the same, okay? So what I mean is, once you have taken the derivative of the outer function with respect to x, keep the nested function inside, and then multiply it by the derivative of the nested function with respect to x. Okay? So let's say we're given a function y of x is equal to cosine of 3x squared. Can you identify the nested function here? First of all, as you can see here, the nested function is the 3x squared. So I'm going to go ahead and write that down here. And the outer function is sine of x capital. The reason why I put a big X, capital X here is because I want you to know what the outer function is and the inner function is for this example. Okay, so I'm going to go ahead and take the derivative of y of x with respect to x. So y prime of x is equal to negative of sine. When I say keep all the nested function inside the f prime of x, what I mean is don't do anything with 3x squared here, okay? This is the first step, okay? First step, take the derivative of this f here. So f prime is going to be the negative sign of big X here, and then replace this big capital X with 3x squared here. And then I'm going to take the derivative of 3x squared with respect to x, and that is 6x. And yeah, this is your answer. And I'm going to move on to some exponential derivatives here. So exponential functions. There are two main things you should know. Exponential functions. So let's say we have a function um, y is equal to e of x, e to the power of x, and we have another function h, which is equal to a to the power of x. So if we take the derivative of y here, so y prime, it's going to stay the same. No matter how many times you take the derivative of e to the power of x with respect to x, it's going to be the same the entire time. One exceptional rule here, okay? So here's h prime. However, in this case, um, keep this exponential term outside here, and then what you're going to do is multiply this by ln of a. Okay? Do you see the difference here? So we'll go ahead and solve a simple problem. So let's say we're given t of x is equal to 2 to the power of x plus e to the power of 3x. And I want to find t prime of x. So what we're going to do is, from this formula, I'm going to go ahead and write 2 to the power of x times ln of 2. And don't forget to apply the chain rule here. So I'm going to add e to the power of 3x and then multiply it by the derivative of 3x with respect to x. So 3. So I'll clean this up here. So t prime of x is equal to the power of x ln 2 plus 3 e to the power of 3x. Okay? All good. Now, I'd like to talk about continuity and differentiability here. So, just remember that if if a point is differentiable, then it must be continuous. So, if differentiable, then continuous. This is the most important thing you need to know about continuity and differentiability. Also, just because a point is continuous, it does not necessarily mean it's differentiable, because if you look at a graph here, say this is y, this is x, even though like let's say for x equals 1, the function is continuous, but what happens if there's like a suddenly sharp u curve here? X equals 3. Just think about this. Like, here's a good example. Like, we can see that the function itself is continuous, but then I see 2 points where I cannot differentiate, x equals 1 and x equals 3. Um, so like that is why, like, although like a function is continuous, it's not always differentiable. A common thing to know for your AP exam. And we'll go ahead and solve a simple problem. So let's say we're given like f of x is equal to, there are two cases, x squared and 2x minus 1. And for the x squared case, if x is less than 1, and for the latter case, if x is greater or equal to 1. So in this case, like we want to analyze like whether like if when we're given a point x equals 1, we want to check whether if it is continuous and differentiable. So when x equals 1, continuous, differentiable. Well, first of all, we can check the continuity by simply like assigning the limit. So let's say if we have limit of x go to 1 of x squared and limit of 2x minus 1, x goes to 1. Let's see the value. So 1 squared is 1, 2 times 1 minus 1 is equal to 1. So when we check the limits, both of them go to 1. So we can say that this function is continuous. So yes, this is continuous. However, now we need to check if it's differentiable. So what we do is I'm going to go ahead and take the derivative of x squared with respect to x and the derivative of 2x minus 1 with respect to x. So d of dx, x squared is equal to 2x, and d of dx, 2x minus 1 is equal to 2. And we plug in 1 for x, so this becomes 2. This is 2, obviously. And we can see that the derivatives are the same, so we can also conclude that it's also differentiable. So when x equals 1 for this function, it is both continuous and differentiable. Okay? Always remember this, that if a point is differentiable, then it's always continuous. Okay? However, just because a point is continuous, it is not always differentiable. Now moving on to implicit differentiation. Um, let's say, differentiation. Let's say we're given a equation here. X squared plus y squared is equal to 25. I'm pretty sure we know what this equation is. So it's basically a circle centered at the origin with a radius of 5, right? I'm pretty sure you've learned this from your geometry class. Some easy circle equation here. Oops. Sorry for my bad drawing of the circle here, but anyways, let's go ahead and find y prime or dy dx. So here's an important information here. The y is actually a function of x. So what we have to do here is we need to take the derivative of y with respect to x when we see the y variable here. So what we do is like, I'm going to go ahead and first take the derivative of x squared with respect to x. So it becomes 2x. Now, y squared. Don't forget to leave the dy dx here because we're using implicit differentiation. The y is technically is a function with respect to x here. So you need that dy dx after, taking the derivative of y squared first. So 2y and then multiply by dy dx. And obviously this 25 is a constant, so that just becomes a 0. And all you gotta do is actually just simply rearrange it. So let's say 2y dy dx is equal to minus 2x because I'm moving the 2x to the right side. All you gotta do is divide 2y both sides, which becomes minus x over y. And that is how you get dy dx using implicit differentiation.